Hey, what's up, guys? This is Chung here. So today, 1835, find the XOR sum of all pairs bitwise and. Okay, so you're given like two arrays, right? And our task is to find the XOR, right, among all the pairs between those two arrays, where the result of the pairs will be an AND, right? Basically, so what this one is trying to ask us to do is that for each of the numbers, for each numbers between those two arrays, we're gonna get like an AND about all the pairs. Basically, we have 1 and 6, right? And then we have 1 and then we have 2 and 6, right? And then we have 3 and 6, and then we have 1 and 5, right? 2 and 5, and 3 and 5. So that's the value, right, for each pair. And then among those values, we're gonna do a XOR, right, among those two, among all of those pairs, right? So pretty straightforward, right? Of course, the brutal force way is that we simply do a loop, right? We do a nested for loop here. We try to get each pair, and then we do an AND, and then we just do an XOR for all those kind of pairs, right? But obviously, given the constraints, which is 10 to the power of 5, that will lead to a O of n squared time complexity, which will be TLE, right? So how can we solve it, right? I mean, actually, there are two solutions here for this problem. The first one is the one I used, during contest, which is a little bit longer to implement. Second one is like a very very easy one by using the distributive property. So let me describe the first my solutions first, right? Basically, since we want to decrease the time complexity. How can we do it? So every time when you see this kind of XOR or an AND, always try to think it in a bitwise way, right? So which means that let's say we have this 1, 2, 3, and 6, 5. Okay. So what is 6, 5? 6, 5 is, so we have 1, 2, 3. 1, 2, 3 is 0, 0, 1, right? 1, 0, 0, 1, and then 0, 1, 0, and then 0, 1, 1. This is array 1, right? And now array 2 we have 6 and 5. 6 is what? 6 is it's 1, 1, 0, right? 5 is 1, 0, 1. Right. So that's basically the six those numbers. So as you guys can see, if we only consider the values for each bit, right? Let's say for this bit, when we compare the pairs, right? When we do the pairs, right? Basically, we're gonna do like the AND, right? We're gonna do the AND for each numbers on this array, and we do another with the other number, with all the numbers here. Okay, so which means that on this bitwise here. So here we have a 1. So 1 do a bit AND with this 2 here, right? So we have what? 1 bitwise with these two numbers, we have 0. We have 0, 0 and 1, right? Because 1 bitwise AND 0 is 0. 1 bitwise 1 is 1, right? And then we have what? We have the second one is 0. Of course, 0 bitwise with anything with bitwise AND will be 0. So that's why we have two zeros here, right? Similarly for this one here, we're gonna have like another 0 and another 1, and that's the that's that's the result for all the pairs for this bit value, right? And then what's next? We're gonna do a bitwise OR, right? among all those values, right? So what does this one get? We're gonna get 0, right? For bitwise OR, right? I mean, say two, because so first is that if this two the same numbers do a bitwise, we'll get 0, right? Doesn't really matter which number it is, as long as they are the same, and then we'll get 0. Okay. And since the possible values between the AND, right, bitwise AND, for this bitwise, it can only be either 0 or 1, so that we can ignore 0, because if they're all zeros, we do a bit, doesn't really matter how many zeros we do a bitwise, or there will still be 0. So, and the value for this one can be either 0 or 1, right? And so when will we get 0? Oh, sorry, when will we get 1? So when the total number of ones are odd numbers, and then we'll get a 1, right? Because for example, we have 2 ones in this case. That's why since all the zeros we do after doing the XOR with all the zeros, there's still 0. So depending on how many ones here, because if we have 2 ones, then the value will be 0. If we have a 3 1, right? Let's say we have another 1 here, the value will be, instead of 0, it will be 1. So if we have another 1 here, this one will become to 0. That's how we do this, right? So now the problems comes down to what? We simply need to count how many ones we have. I mean, after doing this kind of finding all the pairs, right? And how can we calculate all the ones, right? After doing this kind of pairs combinations for array 1 and array 2, we simply need to count the ones at each bit for array 1 and array 2, and then we simply do a count 1 times count 2. That's going to be the total ones, right? We will get after doing this kind of a pair combinations. Because in this case, for example, we have 2 ones in array 1 and one in array 2. That's why the ones we have on this bit will be 2 times 1 equals to 2, right? Similarly, for this one, we have 2 ones and 1 ones here. That's why we also have 2 on the second bit. And when it comes to the third one, right, even though we have 2 ones here, but since we have 0 ones in array 1, so when 0 times 2, we have 0. It means that, we will have 0 ones in this case, because, since, as you guys can see, so every time we have a 0, bitwise AND 1, we'll have 0, right? Okay, cool. So, I mean, now we simply need to create like a counter for ones, for both array 1 and array 2 for all the bit values, right? And then we just do another like for loop, right, to check each bit value and check the parity of ones. And if the parity of ones is odd, we simply add that bit value, corresponding bit value. And since the constraints, the biggest number is 10 to the power of 9, so we can simply use 32 size of bit to represent this 10, the biggest value, right? Cool. So like I said, we have a max bit, right? It's gonna be a what? 32, right? In this case. So I'm going to create 2 arrays, count arrays here. So first one is the arrays count once 1, right? So it's gonna be 0 times max bit, right? And then we have like count 2 to store the bit count for each for both array 1 and array 2, right? So for num in array 1, right, we do a for I in range of max, right? We check if each bit, right? If the bit is 1, we increase the count on for that bit. So if the number and 1 shift I, right, does not equal to 0, it means that that bit is 1, right? So we do a count once 1 I increase by 1, right? Similarly for array 2, right? We simply change this one, right? And then in the end, we have answer equal to 0. We just check the parity for each of the bit, right? The parity of ones for each of the bit. So in range of max, right? So we have total ones. Total ones equals to the count ones I, right? Multiply by the count ones 2. And if the parity of the ones is odd, we know, okay, so this value will be, this bit will be 1. 1 means that, we need to add this value to the final answer, right? And then we return the answer. That's it. Yep. Oh, I used max, okay, later on. So, okay, I'll change this one to max then. Okay, accept it. Yep. And it passed, right? So the time complexity, obviously, we have what? So this is n, right? It's n times 32, right? Yeah, so this is also 32. Basically, time complexity is also, it's all of n, right? And the space complexity is 1 actually, right? Because we only have like up to 32 sides of arrays here. Yeah, so that's basically the first solution. And there's like a easier one, but that one requires a little bit observation for the because we need to use the distributive property to solve it. So what is distributive property? So the distributed property is, let's say we have a1 plus a2 times b1 plus b2. So this one equals to what? Equals to a1 times b1, right? Plus a1 times b2, right? Plus a2 times b1 plus a2 times b2. Okay. Similarly for the XOR and the sum. So for XOR and the sum, so it means that we have, so basically if we have a1 XOR a2, right, and then we and b1 XOR b2, this one equals to what? Similarly for this one, we have a1 and b1 XOR a1 and b2 and a2 XOR b1, last one a2 and b2. So this one, as you guys can see, is exactly what this problem is asking us to do. Right? We have two arrays, right? A and B. So for each of them, we're gonna do like the pairs, combination of pairs. For each pair, we do an AND, and then in the end, we do an XOR. That's why, so this one, as you guys can see, we simply just need to get the XOR for both array A and array B, and then we do an AND between those two numbers. That's it, But the one thing to be noticed that, same thing for this plus and the multiply thing. This property distribution, the distributive property only works in one direction. So which means that, you know, if we change this one to a times, this one change to times, and then we do a plus in the middle, this one does not, you cannot work, you cannot use a like distributive property in this case. You cannot do a A1 times B1 plus A1 times B2, so on and so forth, right? This is known, right? So same thing for this XOR and the AND. So if we change this one to AND, and then this one to the OR, we cannot make this transformation. Just keep that in mind, okay? It just happens to be for this problem. It happens to be we can just use this one. Yeah. And okay, so let's try to implement that in this case. You know, it should be very easy. You know, so we have what? We have num1, right? We have num2 equals to 0, right? And then for num in array 1, right, we do num1 to XOR of num, right? For num in array 2, we do a num2 XOR num. And then we return num1 and num2. Yep, that's it. Run the code, submit. Cool, see? It simply works, you know. And yeah, the time complexity is also O of n, you know. But as you guys can see, this one is faster because we are removing the inner inner loop comparing to the first one. But you know, anyway, yeah, I think that's it for this problem. I'll just stop here and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.